Hello and welcome to this video on finding the nth term of a quadratic sequence. If you haven't already done so, I'd suggest you watch Generating Quadratic Sequences, which is basically the opposite of this video, and also the nth term of a linear sequence. If you can't do a linear sequence, then you'll certainly struggle with a quadratic sequence, so check that one out first. Right, so here we have the sequence that we actually used in the previous video. We generated this sequence, and it gave us these as the first 5 terms. So the goal for this video is, if I've given you this sequence here, can you get back to the nth term there? Now of course we know it in this video, but where does that number actually come from? So the first thing you will do is find the difference between each of the terms in the sequence. So to get from 4 to 22, you must add 18, 22 to 50, you add 28, 38, and then 48. Now in a normal linear sequence, these numbers would all be the same. So if they were all 5, you'd say it's a 5n sequence. But in a quadratic one, they're not going to be, they'll be different. However, if you find the difference between these numbers here as a separate sequence, you'll notice something, and that they are actually the same. So to get from 18 to 28, you add 10, 28 to 38, add 10, 38 to 48, add 10. Now, a really nice little fact to do with quadratic sequences is, whatever this number here is, which is called the second difference, if you half it, so half of 10 is 5, you'll get the coefficient of n squared up here. So that 5 comes from the fact that the second difference is 10. If the second difference was 8, for example, half of 8 is 4, so it would be a 4n squared sequence. If it was 18, half of 18 is 9, it would be a 9n squared sequence, and so on. So when you find the nth term of a quadratic sequence, you find the second difference, half it, and you found out what goes with the n squared. So in this case, 5n squared. Now the question is, where does this bit come from? And in order to do that, what we do is we actually write out what the 5n squared sequence would look like. So above this, I'm going to do this in blue, we've got the 5n squared sequence. And this is simply all the square numbers, and then multiply them by 5. So if we do 1 squared, we get 1, multiply that by 5, and we get 5. If we do 2 squared, that's 4 here, and then multiply that by 5, 20. 3 squared is 9, times 5, 45. 4 squared, 16, times 5, 80, and then 5 squared, 25, times 5, 125. So this is all of the square numbers, and then multiply by 5. Now, the really clever part comes next. What you say is, if this is 5n squared, and this is the sequence I'm after, what do I need to do to each of these terms here to get from 5n squared to my sequence? And that will form a sequence itself. So to get from 5 to 4, I take 1. To get from 20 to 22, I add 2. 45 to 50, I add 5. 80 to 88, add 8. And then add 11. So if we write these numbers in green, you'll notice that these green numbers form a sequence themselves, and this one isn't a quadratic one, it's a nice simple linear one. You should see that the green numbers go up in 3 each time, so that must mean it's a 3n sequence. And to get from 3 to -1 for our first term, I must take away 4. So this 3n take away 4, which we need for our answer, comes from these green numbers, which is the difference between the 5n squared blue numbers and the sequence that we're after. So if we write that in, it's quite simple. All you do is combine your blue bit with your green bit, and then you get your answer, which was the nth term of the sequence. Now there's quite a lot that's just happened in that one there, so I'm going to show you an example from scratch where we don't know what the answer is already. Of course we knew this one. So let's have a look at this one here, and the first thing we do is find these first differences. So for this one we add 11, this one we add 17, this one is add 23, and this one is add 29. Now of course these don't come out the same, we know that, it's a quadratic sequence. It's the second difference that we're interested in. So the second difference is, in this case, all add 6. That means the sequence must have a 3, because that's half of 6, n squared in it. So I'll change colour for this next bit so you can see what's happening. Now above the sequence, with a little bit of space, I'm going to write the 3n squared sequence. So I'll take all the square numbers and multiply them by 3. So 1 squared, that's 1, times it by 3. 2 squared, that's 4, times it by 3, gets 12. 3 squared, and times that by 3, 27. 4 squared, and times that by 3 is 48. And then 5 squared times 3 is 75. So this is the 3n squared sequence. Now all I need to do is work out how to get from 3 to 10. Well, you add 7, and then 12 to 21, that one's add 9, and then 27 to 38, that's add 11. Hopefully you can see what's happening here. This one's add 13, and this one's add 15. So I end up with this green sequence here. And the nth term of that, well, it's add 2 each time, so it's a 2n sequence. And I don't want to start at 2, I want to start at 7, so I add 5 to that. So if you put these two bits together here, you'll end up with your answer, which is 3n squared plus 2n plus 5. And this method always works with all quadratic sequences. Okay, so here are two for you to practice. Press pause and have a go at these. Okay, here are the answers then. So for this first difference, we add 23. For this next one here, it's add 35. For this next one, add 47. And this last one here, add 59. So none of those are the same, so we do the second differences. And this one here is add 12, this one's add 12 as well, and this one's add 12 as well. So it must be a 6n squared sequence, because half of 12 is 6. So above that, we'll write out the 6n squared. And we've got 1 squared times 6 is 6, 2 squared is 4, times 6, that's 24, 3 squared is 9, times 6 is 54, and 4 squared, 16 times 6, 96, and then 5 squared, 25 times 6 is 150. So how do we get from this one to our sequence? Well, this one's at 4, and this one here is at 9, this one here is at 14, 19 and 24. So that green sequence is a 5n sequence because it goes up in 5s, and it must be take away 1 so that we start at 4. And so if we put all that together, 6n squared plus 5n and then minus 1. Alright, for this next sequence here then, so we're adding 2, we're adding 6, we're adding 10, and then we're adding 14. So the second difference, add 4, add 4, add 4. So half of that is going to be a 2n squared sequence. Alright, so above this we'll write out what 2n squared is. So 1 squared times 2, 2 squared times 2 is 8. 3 squared times 2, 18. 4 squared, 16 times 2, 32. And then 50. So that's two lots of all the square numbers. And then what do we do to get to our sequence? Well, that one we had 1. This one's a bit more interesting. We take away 3. This one to get from here to here, take away 7, and this one here take away 11, and this one here take away 15. So this green sequence is a little bit harder because it's decreasing. In fact, it's taking off 4, so it must be a negative 4n sequence, but we don't start at negative 4, we start at 1, so we must add 5 to it to get to our sequence. So the solution to this one, 2n squared, subtract 4n, and then plus 5. That's the end of the video on quadratic sequences, finding the nth term.